Hello. Yeah, we are just going to be doing some notes today. You'll be applying this stuff for the rest of the chapter, so it is very important stuff. Very similar to, just knowing what a function is. A lot of definition stuff today. Um, the application of it's not too bad. However, the extent that you can apply this stuff is pretty in-depth. So this is kind of just basic understanding of things today. And we'll get as far as we can get with it. I will tell you Monday um, is drop everything and read day, which means there will be no math work for you. You are to be reading. I mean, if you want to do math, I won't be there for you. You can always email me and ask me questions on things you don't understand. So, I mean, it is a day that you could be doing work. But you are not required to do any work for me on Monday, with the exception of dropping everything and reading. So, read a book, find your favorite newspaper, read some BuzzFeed articles. I don't care, as long as you are reading. That is your assignment for Monday. Be aware of that. When it comes to science stuff, try your best to get it in by the 30th. On the 4th, May 4th, I am unlocking the next chapter. And again, if you think, hey, if you get 3 weeks to do that, you might not get through the last chapter or whatever it is. I mean, I have chapters planned through. I mean, I could teach a whole other year on biology if I wanted. But it goes on and on and on. So we're going to get through as much as we can, but it is going to unlock the next chapter. And I will probably, after a while, unlock more for those of you that want to keep going with it. It is important information. It's not like it's bad. It's just that you're going to run out of time. I mean, June's going to come and, hey, you're going to be out of school. That doesn't mean didn't learn everything in biology that you could have. You could still keep going with it. But keep in mind, we've been going about 2 chapters each 9 weeks. I mean, they've been pretty in-depth chapters. So um, you got this chapter, and then you'll get another chapter for sure after that. After that, it's going to be kind of up in the air, and I'm not exactly sure how grading's going to work for it, but go with that. If you need more time on the science, take more time on the science. I mean, it gets done when it gets done. As long as you're working, you'll be learning something. Ask questions. Just don't be sitting there thinking, hey, you don't have to do science. You still have to do science. I just know everyone's schedule is kind of weird. Things are strange at everyone's house is different, and I'm trying to just make it a little more flexible for you so you can do anything. Um, I haven't decided what I want to do with Punnett Squares. I have a note here saying Punnett Squares. I might just do a live stream and just be like, hey, pay attention to Punnett Squares, or I might just give you some videos on Punnett Squares. They're really not difficult, but I haven't quite decided on Punnett Square stuff. It's honestly, it hasn't actually been one of my top priorities this week, but I eventually will get into some Punnett Square stuff. They're not hard. It's mostly vocabulary and plugging things into a square, which is pretty simple to do. So, still thinking about that. Uh, with that being said, today in math is mostly notes, but I gave you the notes, so if you want to follow along with that instead of actually writing things down, that's fine with me. But our topic today is slope. And I mentioned before that when you're graphing a line, so for example, we're graphing a line, and this is only true for a line, right? The definition of a line, I guess I'll leave space there, there's 2 words. The definition of a line is either 2 points, so you can graph it with 2 points, or you can graph it with 1 point in the slope. This you should be pretty good at by now. I mean, that's making your XY table, throwing in 2 points, finding your Y coordinates, plotting them, and connecting the dots. It's not difficult. But maybe you're not given all the information you can to get those 2 points. So maybe you're only given 1 point and you're given the slope. You can still graph the same line. So let's talk about what slope is here. I don't need this right now. And we'll graph a couple using slope, what I find. Slope is, another word for slope is gradient. So you might hear people saying gradient, especially if you're over in Europe. But this is gradient. You might have heard the word gradient. Maybe you're driving in the mountains and stuff, and there's a sign that says steep gradient or something. And basically slope is steepness of your line. So we're going to have a lot of different definitions for slope today. They all mean the same thing though. So slope is steepness. It's a measure of steepness. I guess I'll put measure there because we are measuring it. It's a measure of steepness. It's also called your gradient, and it's also going to show rate of change. So let's go ahead and pick a line to graph just to look at it, and we're going to graph the line y equals x. Really simple line. In this case, if you have your xy table, y is going to equal x, so if x is 1, y is 1. If x is 5, y is 5. And there's 2 points, and we'll go ahead and graph that just to get a look at it, to see what it is. We're going to put 1, 1 is here, and 1, or 5, 5 is here. And then when you, excuse me, when you actually graph this line, oh, if I can actually get it there. When you actually graph this line, it looks like that. And of course you have arrows on your sides to show that it goes on forever. The steepness of this line, how steep is this line, is what we're looking at. So we can graph another one. Well, we'll graph a few today. There's no work that's due, but you need to know what I'm talking about. I mean, this is extremely important. So you need to know what slope is today. And hopefully I'm just going to give you a background on slope. It did end up on a Friday, and I didn't want to give you work over the weekend. And Monday you have, read. So we will probably review this on Tuesday as well, but I want to talk about slope today. So slope is steepness. It's a measure of how steep this line is. So if you were to describe how steep this line would be, you would be telling me its slope. And we assign a number to it. And there's a formula for slope. So there's a formula for this, which you need to memorize, or you just kind of remember because it's not a difficult formula. But a formula for slope, or another definition of slope, so this is a mathematical definition. This is the same thing as measure of steepness, is slope equals your change in y over your change in x. And this is a delta, and it means change. Right? Change in y over change in x. Or another way of looking at that is, how is your y changing? So y minus y over x minus x. Or another way of looking at that, and I'll talk about each of these individual too, but another way to talk about that is your y values here is your up and down, it's your vertical. We're going to call that a rise. So it's your change in your rise. How is it going up and down compared to how's it going left and right, which is your x value, because your x coordinates are this axis here. So how's it going left and right, which we're going to call a run. So it's change in rise over change in run, or it's just rise over run. How much did it go up versus how much did it go left and right? Or maybe how much it went up or down versus left and right. So it's just about changing in these things. So how do I change from this point to this point is really what I'm looking at. For science, how do we do the projects that say do with the class or do with a partner? You have people at your house probably that can help you do with a partner. A lot of it's just identifying Mendelian traits. The part that you do with the class, just skip, because you're going to need everyone's information, and I'm not going to sit there and put up a thing being like, hey, put your information here and see how it works, because you're going to need to be waiting for every single person to do it. So I'm just going to say, instead of waiting for everybody, just skip it and get it done. But you're just identifying Mendelian traits, or it's just a project that you could probably do on your own, or you can draft someone from your house to help you out with it. But it's hard to do by yourself unless you like look in a mirror, I guess. But even some of them are kind of tough to see in a mirror. Like, it might be tough for you to determine if you have attached or free earlobes, things like that. So ask someone else to help you with it. But read it and do the best you can with them. I'm gonna grade it based off of completion for you, so it's not gonna be as in-depthly graded because it would have been an in-class lab. Again, just trying to do my best to make a lab work for everybody at home when you need partners and stuff. So try your best is what I'm gonna say. But slope, these are all your definitions for slope. When it comes to points, right? Remember when we were graphing, you could do it with 2 points, right? That will give you 2 x values and 2 y values, so you should be able to use this. In doing so, and we'll look at a couple of things like that. But this here is basically your definition of slope and what you need to know. This you probably won't see much written that way, but delta y and delta you do see a lot in math. It just means change. So that means subtract your y values, and delta x means subtract your x values. So change is subtraction, which you probably know. Like, hey, how much did I grow over this year? You take last year's height and this year's height and subtract the two, you get your change. This here is if you're given 2 points. So if I'm given 2 points, you can find your slope. This here you're going to use if you're given 1 point to find your slope. Well, normally you're given the slope and you use this to find your next point. Given 1 point and slope, and you want to use it to find your next point or your second point. Once you find your second point, you can cross. But that's kind of where you're going to see these. So let's answer our question here, like what is the slope of this line? Slope of y equals x. What is the slope? Or how steep is this line? What is the gradient? What is the change in y over the change in x? So one way to do it is to just plug it into your change in y over change in x. You want to keep things straight. So we're going to call this y sub, we actually call this y sub 2, and y sub 1, and x sub 2, and x sub 1. And that just means that, hey, I'm given 2 points. In this case, my points are 1, 1, and 5, 5. I'm just saying this point is x1 and this is y1 because it comes from the first point. Over here, I'm saying this point is x2 and this point is y2 because it comes from the second point. It does not matter if this was the first point and this was the second point. Your answer would be the same whether you pick this as the first point or this is the first point. It doesn't matter. So just pick one. In this case, as long as you're keeping it consistent, it's going to work. So if this is x1, this has to be y1. Don't make this y2. And then you find your slope from this. And you can do that by plugging into this formula right here. So y2 is your 5. y1 is another 5. And over here you have, I'm sorry, y2 is 5, y1 is 1. And over here you have x2, which is 5, and x1, which is 1. And those both equal 4 over 4, which is reduced down to 1. So here your slope is equal to 1. Just by via graph, stuff like that. So let's do another example just to get you some examples. Let's look at, am I in a different layer? What's all in that layer? Yeah, we can get rid of that. And we can get rid of that. And let's bring back the idea that slope equals delta y over delta x. Again, change in y over change in x. Or if you want to write it out, y2 minus y1 over x2 minus x1. Or if you want, rise over run. So let's give another equation. Let's just pick one. We have y equals 3x plus 4. In this case, we can find 2 points. That's all we need. We're not going to, I mean, we can graph it, but we're just going to find points. Again, I'll pick 0 as a point. 0 times 3 plus 4 is 4. And let's pick 3 as a point. 3 times 3 is 9. 9 plus 4 is 9, 10, 11, 12, 13. So there's 2 points. You could have picked any values for x you wanted because it is a line. It goes on forever. And let's find the slope. So if we want slope, we're going to plug into y2 minus y1 over x2 minus x1. It is just a formula. You plug it in. So over here we can list our values. Let's say this here is our first point and this here is our second point. Again, it doesn't matter which one you would have called which. You'd get the same answer anyways. So we have x1, I'm sorry, y2 is what we want first, so this would be y2. This would be the y coordinate of the second point. So that would be 13 minus y1, which would be the y coordinate of that point, all divided by x2, which is 3, minus x1, which is 0. And here you're going to get 13 minus 4 gives you a 9. And 3 minus 0 gives you a 3, and that reduces down to a 3. So here your slope equals 3. And if I were to graph that, let's go ahead and graph that and see how this works out. There's my coordinate plane. I'm going to cover things up. So if I can go ahead and graph that, I'm only in the first quadrant, so I only really needed that. But let's graph the 2 points. You know how to graph it based off of points, so let's look at the 2 points. We have a 0 and a 4. So we have a point here. And we have a 3 and a 13. So 1, 2, 3, and 13 is up here. So here's our line. There's our line. It has arrows like every other line, showing that it goes on forever. And it has a slope of 3. Well, what does that mean? Well, what we're going to look at is actually this 9 over 3 part first. Right? You know, I'm going to write this as, that's in the other layer. This is also equal to 3 over 1. This way you get a rise over a run. So we'll look at that. So let's look at this 9 over 3, which is the same thing. It's just this is going to match up with our points. So our rise is 9. So if I were to start at my first point, I'd go up 9 on my y. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And you'll note that I'm right here. And then I'd go over 3. 1, 2, 3. And you'll note that I'm at that next point. So if I was only given 1 point in the slope, you can find it. So for example, if I have y equals I don't know, I'm just doing 2x plus 5. I know my slope here is 2 because I'm good at math, and I'll show you how I know that later on. You should notice this value here. Right, that was 3. That was 3 when it was y equals x. That value was a 1. Right, so I know my slope is 2. And I also have a point here, right? If I plug in 0, I get 5, which is this point here. You'll note that's your y-intercept. Let's call it y-intercept, right? So I know a point, which is 0, 5. So 0, 5. Let me do this in a different color. This is going to be blue. Okay, 0, 5. This is all blue. 0, 5 is right here. Now, you could sit there and plug in another point or another x value to get your next point. But in this case, I know the slope is 2, so I'm just going to go 2 over 1. That's up 2 over 1. Up 2 over 1. All these points that I'm putting on here, these are part of that line. So I can sit here and I can go on forever and get as many points. Or I could go the other way, right? Because 2 over 1 is the same thing as negative 2 over negative 1. That means I can go down 2 and left 1. Down 2 and left 1. Down 2 and left 1. You can see how I'm just kind of like drawing that graph. And all these points kind of line up on that same line. You can see how they all go right through it. So that's one way to look at it. And we'll talk about this form later too. But let's look at the different types of slopes you can have. And that will answer Luke's question right there. So let's get rid of, actually let's just get rid of everything. And let's draw some lines. So let's talk about our first line. You don't need to see it very well. Move that over here. There are 4 types of slope that we kind of put things into. So we have lines that look like what we just did. So if I were to get a line like that, this line, as you go left to right, as you're going in this direction, it goes up. We say that this has positive slope. And if you recall what we just did, you'll note that all 3 lines that we drew had a slope that went in that direction. So like y equals x had a slope of 1, and that's a positive number. Y equals 3x plus 4 had a slope of 3, and that was a positive 3. And y equals 2x, what was it, plus 5? I don't remember what I did. But that was a slope of 2, and it was a positive 2. Right? So you have positive slope. You could also have negative slope. And that's pretty easy to see. That's when you have, let's do this in red. That's when it goes in this direction. And again, you have your arrows for it. This here would be negative slope. Negative slope. In this case, when you're going left, when you're reading left to right like you normally read, your line is going down, then it's negative slope. So you have positive slope, negative slope. Then you have 2 other cases. Which is what Luke is saying. What if it's a straight line, like it's not sloped at all? It doesn't have a slope. There's two ways to get it. You can either have try to line this up the best I can. You can either have a vertical line, which this slope equals undefined. you cannot have it. This is not a function. So the slope does not exist. I don't know if that's spelled right. So here you have no slope, or it's undefined. Be aware of that. That is different, and this is where it gets a little confusing. That is different than saying, I didn't want that. That is different than saying you have a horizontal line like this, which is a function, because you'll note it passes the vertical line test, but this slope equals 0. So that is the number 0. So don't confuse not having a slope with a slope of 0. This here, slope of 0, right? Again, rise over run. How much does it go up? It doesn't go up at all, and it runs for, infinity, technically. Right? It goes on forever. 0 divided by infinity is 0. Right? 0 divided by anything is 0. Over here, it goes up infinity, right? But it runs 0, and here you can't divide by 0. So there is no solution to this. Right? You cannot divide by 0. That's just not possible. Right? 1 divided by 0 equals undefined. Weird things happen when you start dividing by 0. So it's undefined. It doesn't work out. So again, just a quick review of that. Right, just so you see them all lined out. You got positive slope, which is going to look like this. You get negative slope, which is going to look like this. You have 0 slope, which is going to look like this. And you have no solution / no slope at all, which is going to be a vertical line. And my lines aren't the greatest there. But those are the 4 types of slope you can get. And it's pretty simple. So again, slope deals with steepness. It equals your rise over your run, which is your change in y. So delta y2 minus y1 divided by x2 minus x1. And just so you know, we are going to it's going to give you, it's going to be called m. We're going to call slope lowercase m. Yeah, I did 1 divided by 0 on the Google calculator and I got infinity. No, you shouldn't have gotten anything. It should say it doesn't work. See? 1 divided by 0 is undefined. Doesn't work. I can show you on the other calculator too. I mean, even this calculator, it won't work. One divided by, oh, I'm sorry. 1 divided by 0, and you get the error. Divide by 0, can't do it. So that's undefined slope or something like that. Again, slope is going to be denoted by the letter m, so pay attention to that. That is the variable we tend to use for the letter m. For slope is m, and let's see. I don't think I want to get into the next part. Let's look at some and let's graph some using slope. So let's say you're given a line that goes through point -5, 6, and it tells you your slope is, I don't know, -1/2. We can graph this. This is enough information. So let's go ahead and graph it, because again, we can graph a line if we know one point and its slope. So we can bring up our coordinate plane here, and we can plot our first point, which is -5 and 6. So -5 and +6 is up here. So there's our first point. And we know our slope is -1/2. Now keeping in mind that means either it's -1/2, or you can look at it as 1/2. Only one of them gets the negative sign. It really doesn't matter which one gets it. So just be aware of that. If you're going to do the -1/2, you're going to go -1 on the y, which is down, and +2 on the x, which would be over here. So your next point would be over here. So you just start at your original point, go down 1/2. If you're following this one, then it's +1 on the y, so you'd go up 1, and -2 on the x, so you would go -2 in the x direction. You'd be here. And you'll note it is the same line, right? If I were to connect the two dots, they go through. I'm having trouble dragging that. There it goes. They go through the same points. Right? And again, you have arrows for things. And then here, you note that your slope is negative. So your line should be going down as you read left to right. So go down as you read left to right. We can plot another one. So again, I'm telling you it's a line. Let's say we have 0, 1, and our slope is 5. Okay. Or here we'll use m, because m equals slope. How about that? We'll get used to using that m. M equals that. So here is an example of one that's a whole number. In this case, you want to make that whole number a fraction, so I am going to rewrite it as just 5/1. So that makes sense. It's going to go up 5/1. So I'm going to start at, I guess I'll do this in blue. All right, so this is the blue one. So I'm going to start at 0, 1, 0 and 1, which is right here. And I'm going to go up 5/1. So these are both positive, so I'm going in the positive direction of y and the positive direction of x. I'm going to go up 5, 1, 2, 3, 4, 5, and over 1 right here. Now the other way to look at this is to say that, hey, these are both actually negative, because -5 divided by -1 is also equal to 5. So you could go in the other direction as well. 1, 2, 3, 4, 5 on the negative y, and 1 on the negative x. And you'll go there. And you'll note that this line is also, at that point, is also in line with the two other dots. And it goes like that. Again, you have arrows, say it goes on forever. And you'll note that this here is positive slope because 5 is positive. So it looks like it's a positive slope. Let's get one with slope is 0. We'll do that in red. So let's say the line goes through points, I don't know, -4 and 7. Actually, let's go down. Let's use that other quadrant. -4 and -7. And let's say our slope equals 0. It has no slope. So you know it's going to be a horizontal line. Right away, these are the easy ones. Hey, that's a horizontal line. I know right away. There's only one type of line that's going to have 0 slope, and that's a horizontal line. So I'm going to find -4 and -7. -4 and -7 is right here. And I know it's just going to be parallel to this x-axis, so I can just go ahead and throw in as many of these dots as I really wanted to. it's going to be parallel to that x-axis. And then you can go ahead and connect your dots. It's a nice fluid line. I guess I put them kind of close. And it's going to be like that. And again, they're going to have arrows on it because they go on forever. So that's, again, you can graph it using just the slope. And in this case, you didn't make any XY tables or anything like that. But that's enough information to do it. I'm going to stop it there, see if you guys have any other questions. What if the slope was a whole number? We just did want the whole number. Yeah, got that. If you have any questions on slope in general, again, today's just more of a definition on what it means. Hopefully you can see how it relates to rise over run. Hopefully you can see what it means by steepness. Hopefully you can identify positive, negative, zero, and undefined slopes. So again, those were our goals. So hopefully you should know what slope is, which is steepness, right? You should know your equation for it, which there's really two of them. I'm sorry, changing y. y1, y2 minus y1 over x2 minus x1, which is also rise over run, which equals slope, which is m. And then you should be able to tell positive versus negative versus zero versus not having a slope. So with that, we're going to stop there. It is pretty much 11:20 anyways. Monday is drop everything and read, so you don't have any math work. We're going to continue with some slope, give you some practice problems with it on Tuesday, and go into different forms of lines. You guys are going to get really good at graphing things, so I highly suggest you invest in some graph paper. It's going to make your life a lot easier. And I guess we'll talk on Tuesday. If you have any questions about anything, including science, send me an email. Again, my goal is to get through, well, this chapter and one other chapter by the end of the year, because it seems to take us like 3 weeks to get through a chapter, which is perfectly fine with me. But I do plan on unlocking that chapter come the end of the month here. So if you have questions, send me an email. Other than that, I'm ending it. So long. Enjoy your weekend. Find a good book or magazine or newspaper to read.